Hi everyone, we are from group 10 and today we'll present about the production of Isoprene. And first of all, let me introduce the group members. The first one is Human Raj, Mufre Ali, Sharmila and Muhammad Aikal.
Isoprene production has many methods, one of which is the dehydrogenation of the C5 hydrocarbons, which is pentane. And here is the process flow diagram for isopentane. Dehydrogenation of the boiling layer of polarized catalyst. This method is considered the main industrial method for the production of isoprene. In the right of this diagram, we have the name of the streams, and on the left we have the name of the units, like the heaters and reactors. And now moving to the reaction equation and mechanism. As you can see, it's a two-step reaction. And in the first stage, we have the dehydrogenation of isopentane to isoamethylene, and this is based on a catalyst of aluminum, chromium, and lithium, or aluminum, chromium, and lead systems promoted in K2O. And for the second step, where isoamethylene is dehydrogenated to isoprene, which is our product, on a catalyst of oxides of iron and chromium as the active elements of this catalyst. Both of these equations are endothermic reactions, and the conditions temperature is 500 to 550 degrees Celsius with 1 atm pressure.
So now I would like to explain about the production of isoprene from isobutylene and formaldehyde. So it is actually a two-step procedure, and as you can see over here, this is the process flow diagram of production of isoprene. I would like to briefly explain about the process. So first of all, the dimethyl dioxide vapor, which is produced from isobutylene, is mixed with the steam and sent to the reactor, in which the temperature is 973 Kelvin. So here the catalyst used is calcium phosphate, and after that, in order to produce the isoprene, it has to pass through a series of equipment such as heat exchangers, rectification column, vacuum column, and finally the recovery column, where the final product, which is isoprene, is recovered. Moving on to the reaction equation and mechanism. So for the reaction equation, basically isobutylene will react with the formaldehyde in order to produce isoprene. It is known as a highly efficient process for isoprene production. And then for the reaction mechanism, the synthesis of isoprene using this method is carried out in two steps. So in the first step, the isobutylene is condensed with formaldehyde in the presence of an acidic catalyst, which is diluted sulfuric acid, to form 4,4-dimethyl dioxide as depicted in the slide. And then in the second step, the 4,4-dimethyl dioxide, which is the intermediate product, is decomposed into isoprene on a solid phosphate catalyst, which is calcium phosphate. So this is how isoprene is produced.
Okay, next, I would like to present on the isoprene production from propylene. So, as you can see, this is the overall process flow diagram of this process. So, first thing first, the propylene will go into the dimerization reactor, where in this reactor, the propylene will go on dimerization process before it goes into the evaporation column, where in this column the catalyst will be separated, and in the rectification column the low boiling hydrocarbon will be separated before it goes into the isomerization reactor for isomerization process. And then it will go into the separation column before it goes into the pyrolysis furnace, which is the reactor for initiated cracking. And then the isoprene produced will be subsequently separated, and purified. So the process condition and catalyst used, the temperature range is from 423 to 573 Kelvin, and the catalyst used is aluminosilicate. Okay. Okay. So next for the reaction equation and mechanism. So this is the reaction equation, which is the propylene will be converted into the isoprene. So actually this process is used after the selective polymerization of the olefins has been discovered. However, there are few disadvantages of this process. The first one is low efficiency of pyrolysis process, and the low isoprene yield, which is just 50 to 60%, and the overall yield is also low, which is just 45 to 50%. And this process is only usually used on a limited scale. So for the reaction mechanism, there are three reactions involved. First one is the dimerization of propylene to form 2-methylphenolene, where then the second reaction is the isomerization of 2-methylphenolene to 2-methylpentene, and finally the demethanation, also known as cracking, of 2-methylpentene to form isoprene. So this is generally how um, propylene is used to produce isoprene. Thank you.
Among these three processes, currently industry are focusing on the isoprene production from propylene process due to its advantages of the process. Isoprene production from the propylene process has been trusted workhorses in the refining industry to meet the demand for tires. And that's all from us. Thank you.